The OSIRIS-REx spacecraft is en route to the carbonaceous asteroid Bennu, and the plan is to use Earth's gravity to get it there. The spacecraft will come within 17,000 kilometers of Earth as it uses the planet's gravity to slingshot itself toward its destination. The maneuver is known as Earth Gravity Assist and will allow the spacecraft to match the speed of the Bennu asteroid, says Professor Phil Bland from Curtin University in Western Australia, who will be watching the event unfold. It turns out, with a slight modification to our cameras, and the help of some amateur astronomers in Australia, we should be able to see it, and track it as it flies over, he told news.com.au. He's a member of the OSIRIS-REx science team and also leads an Australian group called the Desert Fireball Network, which, as he puts it, tracks fireballs coming through the atmosphere. Aside from sounding really cool, the project helps answer some fundamental questions about the origin of celestial materials that land on Earth. We don't know where meteorites comes from, Professor Bland said. Basically, we've got all these samples that land on Earth, but we don't know the journey they took to get here. So what we try to do with the Fireball Network, we track everything that comes through the atmosphere over a large fraction of Australia, he said. Automated observatories dotted across the country monitor anything that blazes through the sky, which gives astronomers a good idea of where meteorites will land and roughly where they came from in the solar system. It's kind of like giving us a geological map of the solar system, Professor Bland said. But on September 23, all telescopes and cameras will be firmly fixed on NASA's OSIRIS-REx spacecraft as it gets flung overhead. Source Twitter. The rare encounter offers an opportunity to highlight the capabilities of the Desert Fireball Network and planetary science research in Australia, Professor Bland said. And he hopes more members of the public will get involved in observing the flyover. It helps the NASA folks to get as many observations as they can as it comes overhead, so they can test the trajectory, he said. So they can check the real observations match what they're getting from the probe. And you won't necessarily need a sophisticated telescope to join in on the fun either. It's not going to be visible to the naked eye, but really any amateur astronomer with a half-decent telescope should be able to do it, the professor said. Or a big lens on a regular camera like a telephonic lens, they should be able to pick it up and see it themselves. Source supplied. The mission's spacecraft was launched on September 8, 2016 and will take about another year to reach the asteroid Bennu. Once there, it will spend about 12 months on the surface of the space rock, mapping and analyzing the asteroid before embarking on its return journey. If all goes according to plan, it will return to Earth in 2023 carrying a sample from Bennu, which could help us record the early history of the solar system and better understand the molecular precursors to the origin of life. One of the reasons we want to go to the asteroid is that these materials haven't really been altered that much since the solar system formed, so they can tell us a lot about how planets came together, Professor Bland said. There's a lot of really big questions we don't have the answer to for that. And NASA says the flyby will also give researchers a unique opportunity to observe our home planet. The team is eager and ready to execute the Earth Gravity Assist, said Rich Burns, who is the OSIRIS-REx project manager at NASA's Goddard Space Flight Center in Maryland. Not only will it be a significant change in trajectory, putting OSIRIS-REx on track for rendezvous with Bennu, it also represents a unique opportunity for the OSIRIS-REx instrument to observe our home planet, he said. It is fantastic that ground-based observers are also taking the opportunity to image OSIRIS-REx. Source Twitter. Why Bennu? There are over 500,000 known asteroids in the solar system, so why did NASA choose Bennu? At the time of the mission's asteroid selection in 2008, there were over 7,000 known so-called near-Earth objects, NEOs, but only 192 had orbits that meant they would be close enough to make them accessible. The most primitive asteroids are carbon-rich and have not significantly changed since they formed nearly 4 billion years ago, and Bennu happens to be one of the few known asteroids on the list which had the right carbon composition. It also has a diameter of about 500 meters, making it stable enough to host the spacecraft because asteroids with smaller diameters rotate more rapidly, causing problems for a mission like this. For instance, with a diameter of less than 200 meters, an asteroid spins so rapidly that the loose material on its surface can be ejected from it. While Bennu happens to be the Goldilocks candidate for this particular mission, even